Good morning, everyone. Today we will be discussing the topic TRIAC. I believe that this video about the topic will be very useful for all students. Okay, now let us start the topic. First, let's understand what is TRIAC. TRIAC stands for Triode for Alternating Current. Triode for Alternating Current. A TRIAC is a three-terminal semiconductor device that can conduct current in both directions when it is triggered. It is mainly used for controlling AC power. The TRIAC of maximum rate 16 kilowatt is available in the market. TRIAC is the one of the member of thyristor family. Thyristors are widely used semiconductor-based devices for the regulation of power. However, they can conduct in only one direction, just like a diode, which makes them suitable for DC power regulations. Whereas TRIAC, which belongs to the family of the thyristor, can conduct in both directions as well as offer full control over the power supplied. Therefore, they are used for AC power regulation. It is made from the combination of two SCRs in anti-parallel with their gates joined together. Already we know SCR. SCR means silicon control rectifiers. The three terminals are gate, MT1 and MT2. Another one is gate. It does not have an anode and cathode like a thyristor because it can conduct in both directions, and it does not matter if the terminals are swapped. TRIAC can be triggered into conduction by either positive or negative gate current in both directions, while it switches off when the main current falls below the holding current limit. The symbol of TRIAC represents two thyristors connected in anti-parallel having a common gate. It's equivalent to thyristor structure. It also given for better understanding. Just like thyristor, it has three terminals, but their names are different except for gate. It is due to the fact that each terminal is made by connecting the anode and cathode of SCR together. Therefore, both terminals are either called anode or main terminal called as MT. Next, we see the construction of TRIAC. TRIAC is a four-layer device that is made from a combination of two anti-parallel SCRs having three terminals, gate MT1 and MT2. Both main terminals, whereas MT1 and MT2 electrodes are connected with both P and N regions of both SCRs. So that is can conduct current in both directions. The gate metallic electrode is also connected with both P and N regions. It allows the TRIAC to be triggered by both positive as well as negative gate currents. TRIAC is a bidirectional switch. It can conduct in both directions, but it is not symmetrical. Its asymmetrical structure is the reason TRIAC has asymmetrical switching. Next, we see the operation of TRIAC. The operation of TRIAC resembles thyristor. When the voltage is applied, it will not conduct unless the voltage does not exceed the breakover voltage VB0 or a gate pulse is applied. As we know, the TRIAC can conduct for both polarities of applied voltage, and it can be triggered by both polarities of gate voltage for either direction. Therefore, the TRIAC can operate in four modes. First one, mode 1. When MT1 is equal to positive and gate terminal is positive. In this mode, the applied voltage at MT1 is positive with respect to MT2. By applying a positive gate pulse, the TRIAC will trigger to forward conduction and the current will flow from MT1 to MT2. Next, mode 2. When MT1 is equal to positive and gate terminal is negative. So in this mode, the applied voltage is the same. MT1 is positive with respect to MT2, but the gate pulses is negative. Since the gate is connected with the N region of TRIAC, it will trigger it into forward conduction while the current direction will remain the same. Third one, mode 3, when MT1 is equal to negative and gate terminal is positive. In this mode, the applied voltage polarities are swapped, whereas MT1 is negative with respect to MT2, but the gate pulse is positive. The gate voltage will trigger TRIAC into reverse condition from MT2 to MT1. Next we see the mode 4, when MT1 is equal to negative and gate terminal is negative. Then both MT1 and gate terminal is negative. In this mode, both the applied voltage and the gate voltage are negative. The negative gate pulse triggers the TRIAC into reverse conduction. Mode 1 and mode 2 represent an operation in the first quadrant where the current and voltage are positive, while mode 3 and mode 4 represent operation in the third quadrant where the voltage and current both are negative. While the gate pulse can trigger TRIAC in either direction, it is best to use a positive gate pulse for operation in the first quadrant and negative gate pulse for operation in the third quadrant due to their increased sensitivity. Mode 2 and 3 require more gate current than mode 1 and 4 to trigger TRIAC. Next we have to see VI characteristics of TRIAC. This VI curve shows the relationship between the applied voltage and the current flowing through the TRIAC. It operates in only the first and third quadrant. It is operating is the same as SCR, but it can also operate in the third quadrant. The current I increase when either voltage V exceed the breakover voltage VB0 or if a gate pulse is applied. As soon as the device switches into on state, the voltage reduces on state voltage and the current exceeds. It will remain in on state until the current reduces below holding current IH. Holding current I sufficient H. TRIAC is the combination of two SCR in a single package. Therefore, it also has the same electrical characteristics as individual SCR in each direction, such as breakdown voltage, trigger voltage, holding current. Then advantage. It can conduct regulate both of an AC waveform. It is compact and require a small heatsink as opposed to using two ACR. It requires only one fuse for protection. Positive as well as negative gate pulse can be used to trigger TRIAC. Next, disadvantage. Its switching is asymmetrical for both of AC. So asymmetrical switching creates harmonic in the system, causing numerous problems. Next, its power rating is lower as compared to SCR. It's less reliable than SCR. It has a lower switching speed, requires caution while triggering, as it can be triggered in either direction. An application. TRIAC is used for low to medium high power regulations. Due to their asymmetrical switching, a DIAC is used in series to its gate terminal to provide symmetrical triggering. A combination of both DIAC and TRIAC in a single package is available, which is known as a quadrac. They are used for controlling, mainly used in controlling the speed of motors, fan and light dimmers, as well as heat control applications. Thank you.